Assalamualaikum warahmatullahi taala wabarakatuh. My name is Raimi bin Muhammad Riza and my matrix number is 01DDT23F1111. And today I will be present about mini project data structure for question number one. So, Aiman joined a programming competition in his faculty. He was given 1 week to solve a problem. Aiman asked for help to construct a program to reverse the word that entered the program. For example, ALI, that output will display ILA to the screen. Aiman want you to use a stack to store the inputs. So let's continue for the coding. That I will use a hashtag include iOS stream, include string, and also include stack because of in the question that need to use stack and also using namespace std. So for the input, I will be declare using a string and stack char s. So see out enter a word that will be announced to the user that need to put a word. So for the word will be go to I save to the input, and that I use a for loop and char ch input and s dot push ch. So for the string reverse, while s dot empty reverse plus equal s dot top. So this is where the word will be reversed. The coding will be make the word will be reverse. So s dot pop and c out reverse word. So this is where the reverse word will be output and will be displayed. So for for the output will be go like this. Enter a word ALI and also will be show for the reverse word that will be ILA. So that's all from me. Thank you. Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rizal bin Muhammad Rizwan. My matrix number is 01DDT23F009. Yeah, I'm going to explain about question 2, which is we need to develop a food ordering system for XYZ restaurants. This system should use first in, first out concept to manage first order. So when the customer places an order, it gets added to a stack. And to enter the order, you need to use the queue link list data structure contain a stack of order for one customer. And then you can pop the start for when it's done. Alright, we'll look at the code. So there is a structure for the code in for order in the stack. And it is for the structure for customer in the queue. So that every time there is a new customer, it will enter this queue. And then we'll look at the class queue, private customer. It is for the managing customer orders. So every time there is a new order, this will put inside this queue. Next, we'll look at this. Uh, next, we'll look at the uh this this. Next, we'll look at the next block of code. This is the where we put the customer order. So every time there's a new customer, it will put inside this here the name, order, and number order. So there is a new order for the customer. It will put there is the code for it. Next, we'll look at the next block of code, which is here. Alright, next we'll look at the second part of the code, which is the void display queue. This void display queue, it's display the customer in the queue. So after that, we put the customer in the queue. This code will display the current customer. This is for process order of the first customer in the queue. So after we add the order for the customer, this line of code will add um will process the code. This is for processing the order. And this while is for proceed all the order in the customer. So until that is zero order, it will not finish. Right, there is the input. So the first order is the first queue is nasi lemak and Milo. It's my order. The customer name Rusafi. And our second queue is curry puff. Our second order is curry puff. The customer is Arik. Our third order is nasi goreng and es limau. And the final customer is Anif. So after running the code, the output will be like this. Will show that the customer in the queue and the processing the order, and then for all the customer. Thank you. And that's all for my part. Thank you.
Assalamualaikum. My name Muhammad Anif Farhan bin Abdul Rahman. My metric number is 01DDT23F1186. Now I want to explain the question 4 for a mini project data structure. Now we can see question 4 is the question is based on figure below. Illustrate the steps to find the target key of 52 by using linear search A, linear search method, B, binary search method. So this is the figure. So the first for the index 0 is 8, index 1 11, index 2 19, index 3 25, index 4 34, index 5 47, index 6 52, index 7 55, index 8 58, and the last index 9 60. Now we go to the answer for the A linear search method. So the first we search the 52 at the index 0. The index 0 is 8. So 52 equal 8 is not so it means 52 is not equal with 8. Now we go to index 1 11. 52 is not equal with 11. And then we go to index 2. Index 2 is 19. So 52 is not equal with 19. And for the index 3 is a 25. Now we want to search a 52. So we 52 equal 25. But is 25, 52 is not equal with 35. Now we go to index 4. Index 4 is a 34. So 52 is not equal with 34. And for the index 5 is a 47. 52 is not equal with 47. And the last is a index 6. Now we found the 52 equal to 52. So with 52 is equal with 52. And we found the key of a 52. And then this is how we use a binary search method. So for the first, we find the mid first. So if have a two mid like index 4 and index 5, if we want to find a mid, we go to first index 0 and last plus index 9. So 0 plus 9 get a 9, and divide to 2 is get a 4.5. So we take a 4.5 is index 4. So the index 4 is a 34, but we want to find a 52. So 52 is a more than a 34. And for the second step, um the like I said, for 54 is more than a 35. So we focus at the right only, and at the left we will forget it, and now the mid at here we will forget it because before this it 52 is more than. So if the more than, we focus for the here. So at here we find the mid is a 55, the first is a 47, and the last is a 60. So the 52 is a less than 55. So it means we forget this, and we focus at here for index 5 and index 6. After that, we need to find a mid, and the 47 is become a first and mid, because if we want to find a mid, we need to see the first and last, and the first and last is index 5 and index 6. So the first index and the last index will be plus 5 plus 6, 11, and divide to 2 and get a 5.5. So we declare that 5.5 is the 5. So the 47 is be a mid. So 52 is a more than 47. So for the last, we found the 52 after all step we do, and we found the 52 at the index 6. So that's all from us to present our data structure mini project. So thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zarfan bin Saifuddin Zainib. I'm matrix number 01DDT23F1130. In this video, I'm going to explain, I'm going to review and explain the code that I have made based on the question from unit project of the FC30233 data structure. So, here's the question. Write a C++ program to show implementation of binary search tree using linked list. Your program must include the basic operations in binary search tree, including creating BST, inserting item into BST, deleting item from BST, and display data in BST. Without further ado, let's take a look at the code. Here, as we can see, just like always in any C++ code, we need to put preprocessor directive first at the top. I'm using the IO stream, and then we need to define the structure of the tree, namely node. The members of the node is integer item, node pointer left child of the tree, node pointer right child of the tree. Then we have a function called create node. This is for the creating the tree for the BST using the parameter from the integer item of node. Here it create an object based on the node called new node, and then the object called item from the node, and then here it assign the left and right of the node as a null pointer, which means no value. After that, it goes to null. After that, we have the insert node, which is for inserting item into the BST using if else if selection. The parameter of the function based on the node pointer root and integer item. So in the selection, case 1, if root equality null pointer, it will run root equals to create node item. In the case 1, if it's true, it will run the create node function. If not, the item that we just inserted based on the condition lesser than root point item. It will run the root point left equals to insert node root point left item, which means the item will be inserted in the left child of the tree. Otherwise, the item will be inserted in the right child of the tree and then return root. After that, we have a function called find min. This function is used for finding the lowest value of the item inserted. After that, we have a function called delete node to delete an item from the node using the parameter node pointer root, node pointer root, and integer item. Using the nested if as if. In the first case, if root equality null pointer, it will return root since null pointer has no value, so it cannot delete any item. If not, it will run the condition item lesser than root item. It will run the root point left equals to delete node. So it will delete the item from the left child of the tree. If not, for the second case, it will run based on the condition item bigger than root item. Root point item. It will run root point right equals to delete node root point right item. In this case, it will delete the right child of the tree. Otherwise, it will go to the nested as if. It will go to the nested as. In the first case, if root point left equals equality null pointer, it will move. It will run not node pointer temp equals to root point right. It will move the root point right to a temporary place, and then it will delete the root. After that, it will return the temp. If not, the root point right equality null pointer, it will run the same code from the previous case. The only difference is it uses the left child of the tree. After the nested if as if and it will go back to the main if as if selection, which is here it will run node pointer temp equals to find min root pointer point right. It will move the item in the temporary into the find min function. Other than that, the root item equals to temp point item, and then the root right equals to delete node root right temp equal point item, and it will return root. After that, we have a void function called in-order traversal for the later use. It uses the not point, the root as the parameter. In the function, it will run the if selection. So in it, if root not equal to null pointer, it will run in order traversal, which is this function, using the root point left as the parameter, and then it will print out the item from the root item, and then it will run the in order traversal for the root point right, which is the right child of the tree. And that's it for the explanation of the functions in use in the code. Now we go to the main function. First of all, we declare the not pointer root equal to null pointer as the root for the code. After that, we insert the code. After that, we insert the item. Root equal to insert item. After that, we insert the item. Root equals to insert not in parameter root 50, which means the root that are going to be used in the function, it runs the insert not function in here. As we can see, the parameter for the insert not function, it use the not pointer root and integer item. As we can see, this is the not pointer root and this is the integer item. After that, they run again they insert again another item here. This time the root gonna be the 50, and then after that it will run again the insert code, and just as before, the root will be using the previous inserted item until the last one, which is item 80. After that, we can display the code. In this case, I'm using the in order traversal for the displaying. So here it will call the function in order traversal using the root, the last root, which is going to be 80 as the parameter, and then another code, and then another display, which is in order traversal, but there will be a deleting occurred. In this case, the root equals to delete not in parameter root 20 in the this line of code will run the delete not function, this one. After that, it will run again the in order traversal function, just like the previous display, and return 0 for the main function. Now let's run the code. As we can see, the in order traversal we can see it's lined up in increment. And the second display, after deleting the item 20, we only now have item 30, item 40, item 50, item 60, item 70, and item 80. And since there's no error in the code, I think that's it from me. Thank you.